Hello guys and welcome back. Today is part 4 of the AC motor control methods tutorial. Today we're going to talk about auto transformer starters. We're going to look at the construction and operation of the auto transformer, look at the diagrams up for the auto transformer. We're going to look at how to connect squirrel cage motors for two auto transformer starters. We're gonna look at the definitions by open transition and closed transition starter, and we're gonna look at the image and see how to troubleshoot in connections for auto transformer starter. Auto transformer reduced voltage starters are similar to primary resistor starters in that they are used primarily with an AC squirrel cage motor to limit the inrush current or to lessen starting strain on driven machinery. This type of starter uses auto transformers between the motor and the supply lines to reduce the motor starting voltage. Taps are provided on the auto transformer to allow the user to start the motor at approximately 50%, 65%, or 80% of line voltage. Most motors are successfully started at 65% of line voltage. In situations where this value of voltage does not provide sufficient starting torque, the 80% tap is available. If the 50% starting voltage creates excessive line drop to the motor, the 65% taps are available. This way of changing the starting voltage is not usually available with other types of starters. The starting transformers are inductive loads, therefore they momentarily affect the power factor. They are suitable for long starting periods. Auto transformer starters. To reduce the voltage across the motor terminal during the accelerating period, an auto transformer type starter generally has two auto transformers connected in open delta. During the reduced voltage starting period, the motor is connected to the taps on the auto transformer. With the lower starting voltage, the motor draws less current and develops less torque than if it were connected to the line voltage. An adjustable time delay relay controls the transformer from the reduced voltage condition to the full voltage. A current sensitive relay may be used to control the transfer to obtain current limiting acceleration. To understand the operation of auto transformer starter more clearly, please see the following image. While the start button is closed momentarily, the timing relay is energized. The relay maintains the circuit across the start button with normally open in instantaneous contact or TR, which now closes. Starting coil S is energized for terminal 4 through the normally closed time delay in opening contact TR through the normally closed inner lock R. Through coil S and through the overload contact through L2. Completing this circuit, the running starter cannot be closed at this point because the normally closed inner lock S is open and the mechanical inner lock is operating. After a preset time period, T hard, the normally closed contacts open and the normally open TR contacts close. When coil S is de-energized, normally closed interlock S closes and energizes the running starter on. The contact switching arrangement for a typical power circuit can be seen in the next image. Where two transformers are used, there will be an imbalance in the motor voltage during starting. This imbalance will produce a put variation of approximately 10% in the running position. The motor is connected directly across the line and the other transformers are disconnected from. As a result, only 3 contacts are shown. 4-line voltage is applied to the outside terminals of the outer transformers on starting. Reduced voltage for starting the motor is obtained from the outer transformers taps. The current taken by a motor varies directly with the applied voltage. Starting compensators, outer transformers, using a 5-pole starting contactor are classified as open transition starters. The motor is disconnected momentarily from the line during the transfer from the start to the run condition. Closed transitions connections are usually found on standard size 6 and larger starters. For those who are not familiar with the starters, starters come in sizes like size 0, 1 through 2, 3, 4, 5, and in this case 6. So we said the closed transition connections are usually found on the standard size 6 and larger starters. For the closed transition starter, the starting contactors consist of a 3-pole iniesta contacts and a 2-pole S1 contactor, operating independently from each other. During the transfer from start to run, the 2-pole contactor is open and the 3-pole contactor remains closed. The motor continues to accelerate with the outer transformer serving as a reactor. With this type of starter, the motor is not disconnected from the line during the transfer period. Thus, there is less line disturbance and a smoother acceleration. The outer transformers are de-energized while in the running position. This is done to conserve electrical energy and to extend their life. The CT designations in the above image indicate current transformers. These transformers are used on large motor starters to step down the current so that a conventional overload relay and heater size may be used. Magnetic overload relays are used on large, reduced voltage starters also. This is it for part 4. And thank you guys for watching. Again, please like, share, and subscribe. See you in the next one.